So we have to evaluate this integral. Before doing that, I think I should take you to a very important result, namely this one. The sine of mx, sine of nx is cosine of is the same thing as saying a half of cosine of m minus n minus cosine of m plus n. I just want to prove this result very quickly by expanding this particular point. So I have to use compound angle formulas, of course, but I just want to prove that this is the case. So cosine of m minus n is just cosine of m, cosine of n plus sine of m, sine of n. Now this is just using a compound angle type of formula. Then we have to subtract, of course. We have to subtract cosine of m. Now we're expanding this part. Sine of cosine of n minus sine of m, sine of n. And now I want to distribute the negative sign here as follows. So it should be a half cosine m cosine of n plus sine of m sine of n minus cosine of m cosine of n, since we distributed the negative sign now. And now negative plus negative, so it should be positive, right? Because these two negative signs should cancel. So it should be positive. Hang on, let me just rub this out. So positive sine of m sine of n. Now we notice that positive of cosine of m cosine of n should cancel with positive of cosine of m cosine of n. And then we have these two terms. This term is the same as this term, so it's just 2 times of this term. So just write this down on another page. So it's a half of sine of m, sine of mx rather. Excuse me. Sine of mx, sine of nx times 2, since there are 2 terms that are the same. Of course, a half times 2 is 1, and so we get sine of mx sine of nx. And so we've essentially proved the result that we had here, right? So this is the same as this. And now we can use this result to solve for this one here. So we just go cosine of, so it should be from negative pi to pi, cosine of, let this be m, and let this be n. So cosine of should be a half right here, half of cosine of 3 minus 4x minus a half of cosine of 3 plus 4x dx. So I could just take the half outside, factoring a half out, since both these terms are a half. Negative pi to pi. And then, okay, this is 3 minus 4 is cosine of minus x. And then we have, again, we have 3 plus 7, which is just cosine of 7x, cosine of 7x dx. And, right. So now, since cosine is an even function, so cosine of negative cosine is the same thing as cosine of positive cosine. Why? Because this function is even, and of course this function is even. And now we have to remember an important result, namely, if we have an even function over a symmetrical interval, in this case, from negative pi to pi, it's symmetrical about the point 0. So we just multiply the integrand by 2, and then we evaluate from 0 to pi. That is 0 times half of the interval, which is pi. Half of the magnitude of the interval, which in this case should be pi. And so let me just continue here. So it should be 2 times from 0 to pi, using that result that both terms in the integrand are even. So multiply these two out, and then we had cosine of x, and we had plus of cosine of 7x dx. Just check if that's true. Okay, that's true. And now we just find the antiderivative of this integrand. So what's the antiderivative of cosine? So it's sine, right? If we differentiate sine, we get cosine. And then same thing here, just sine of 7x. The only difference is we have to multiply by 1 over 7. Then we evaluate from 0 to pi. And here just sine of pi plus sine of 7 pi times 1 over 7. And then we have to subtract 0. So if we substitute 0 for here, say this is 0, from 0, this whole thing will be 0, right? So we need not include this term here. So what's the sine of pi? So the sine of pi should be negative, it should be negative 0. It's just 0, right? Then 7 pi, it's the same thing. It should be 0. So the whole integrand is just 0 here.